For years, Google and OpenAI set the pace in AI video generation, but a new contender is shaking that confidence. SeeDance 2.0. Launched by ByteDance in 2026, it generates high-resolution video using not just text, but images, clips, and sound, faster and with more flexible input than its Western rivals. Silicon Valley insiders are suddenly asking if China has found a shortcut in the global AI race. How did this happen? And what exactly makes SeeDance 2.0 so advanced? SeeDance 2.0 stands out for how it lets users mix and match different types of input, text, images, short video clips, and even audio files, all in a single request. Instead of being limited to just describing a scene with words, creators can upload up to 9 images as visual references, 3 video snippets for motion or style, and 3 audio tracks for mood or timing. This flexibility gives users a kind of director's toolkit. Want a character's face from one photo, the movement from a dance video, and the soundtrack from your own audio file. SeeDance 2.0 can blend all those elements into a single, coherent video. In practice, this means much more control over the final result compared to Western models like Sora and Veo, which typically accept only text and maybe 1 or 2 images. The ability to fuse multiple types of input opens up creative possibilities, making it easier to get exactly the look, sound, and feel you want from AI-generated video. SeeDance 2.0's technical claims go beyond creative control. The model generates video at a native 2K resolution, 2048 pixels across, making it one of the highest output systems available for public use. Each request can produce clips up to 12 seconds in length, a duration that gives creators room for multi-shot sequences or extended action, rather than just short bursts. Under the hood, SeeDance 2.0 is built on a diffusion backbone, a method now standard for generating realistic images and video. What sets it apart is its temporal attention module, designed to keep motion and audio in sync across every frame. This architecture is meant to reduce the flickering and drift that often break the illusion in AI-generated clips. While ByteDance has shared these output specs and broad architectural details, the company has not released full technical documentation or allowed outside audits. That transparency gap leaves some questions about how these results are achieved, but the headline numbers, 2K video, up to 12 seconds, and a diffusion-based engine, set a bold benchmark for the industry. Resolution and control are the two axes where the differences between these AI video models come into sharp focus. Sora, from OpenAI, caps its video output at 1080p, which is considered high definition, but falls short of the 2K ceiling claimed by SeeDance 2.0. Google's Veo reaches up to 1080p as well, though many of its public demos stick to 720p for stability. Where Sora stands out is in its unique ability to insert user avatars directly into generated scenes, a feature that has drawn attention from filmmakers and digital artists alike. Veo, on the other hand, has built its reputation on precise reference control, letting users steer the look and feel of a video by supplying a single image or a pair of frames for start and end points. SeeDance 2.0 pushes further on controllability, allowing multiple reference images, video snippets, and even audio tracks to be combined in one request. The result is a spectrum. Sora offers realism and avatar integration. Veo delivers tight reference control. SeeDance 2.0 maximizes creative input. Each model's strengths and trade-offs become clear when placed side by side, especially for creators who want both high resolution and granular control. Accuracy and speed have become the battleground for next-generation AI video models. When it comes to keeping motion smooth and realistic from one frame to the next, a quality known as temporal coherence, OpenAI's Sora stands out in independent tests. Its videos show fewer glitches, with objects and people moving in ways that obey real-world physics. Google's Veo, meanwhile, scored highest in a recent human preference study, with viewers ranking its clips best overall for natural flow and visual consistency. SeeDance 2.0 claims to match this level of stability, but so far, there is no third-party benchmark to confirm it. What is verified, though, is how quickly SeeDance can deliver results. A 5-second high-definition video is generated in about 41 seconds on an NVIDIA L20 GPU, making it one of the fastest in its class. This speed matters for creators who want to iterate quickly or produce content at scale. Still, the lack of outside validation for SeeDance's physics accuracy leaves a gap, one that keeps industry analysts cautious as they weigh its real-world impact. Inside Google, a leaked memo warned that SeeDance 2.0 could erase their lead in AI video within a year. At OpenAI, the chief technology officer admitted on stage that the pace of Chinese innovation is forcing a rethink of Sora's roadmap, especially in areas like speed and multimodal input. These are not just words. On Douyin, creators using SeeDance 2.0 are seeing engagement triple compared to traditional videos. For companies that have dominated AI development for years, this spike in user attention and the rapid rollout of new features is a direct challenge. The competitive pressure is no longer theoretical. China's approach gives SeeDance 2.0 an extra push beyond just technical features. The Ministry of Industry and Information Technology launched a smart city pilot in Chengdu, testing SeeDance for public service videos. Major funding followed, as the National Development and Reform Commission approved a 500 million yuan subsidy to boost domestic AI video chip production. ByteDance also introduced a digital watermark module on February 15, 2026, embedding invisible signatures in every generated clip. These steps combine government backing with early safety measures, giving China a systemic advantage that is hard for rivals to match. Today, SeeDance 2.0's leap in speed and input flexibility forces global tech giants to rethink their lead. The AI race is no longer theoretical. It is unfolding right now. What do you think?